Welcome back. In a previous video, we started solving this question and we considered the first part, that is the height of the pyramid, and we got 3.5 centimeters. In this video, we are going to concentrate on the second part, that is finding the total surface area of the pyramid. So the total surface area of the pyramid. In the first video on pyramids, we learned that the total surface area of a rectangular pyramid is equal to the area of the rectangular base plus the area of the triangular faces. The base of this pyramid is a square, so the total surface area of this pyramid is going to be the area of the square base plus area of the triangular faces. This is the net of the pyramid. So if you open up this pyramid, we are going to have a figure like this, where A, B, C, D is the base of the pyramid, and these are the triangular faces. So to find the total surface area of this pyramid, we need to find area of the square base, then we find area of each of these triangles, and we add them together. Let's first begin with the square base. A, B, C, D is the square base. It has the length of the side as 5 centimeters. We know that area of a square is equal to length times length. Here the length is 5 centimeters. So area of the square is equal to 5 centimeters times 5 centimeters, and that will give us 25 centimeters squared. So the area of the square base is 25 centimeters squared. We are done with the base. We now concentrate on the triangular faces. If you look at these triangles very well, I'm going to call this first one here triangle 1. I'll call this triangle 2. I'll call this one triangle 3. And I'll call this triangle 4. You can see that all these triangles, triangle 1, 2, 3, 4, have the same dimensions. They are all equilateral triangles with sides 5 centimeters. So all that you need to do is to find the area of just one of them, and you multiply your answer by 4, because area of triangle 1 will be the same as area of triangle 2, and to be the same as area of triangle 3, it will be the same as area of triangle 4. So if I'm able to find area of triangle 1 and multiply the answer by 4, I'll get the area of all the triangles. So let's pick one of them and find its area. So I'm going to pick the triangle OAB. So triangle OAB. For triangle OAB, the side OA is 5 centimeters, as you can see here. The base AB is 5 centimeters also. In the video on triangles, we learned how to find the area of an equilateral triangle. We learned that the area of a triangle is equal to half times base times height. So for this triangle, we have the base. What we need to do is to find the height. If we draw a line from O to meet AB, I'll call the meeting place point M. The angle created there will be 90 degrees. This perpendicular line is the height of the triangle. We learned how to find this when we were finding the area of an equilateral triangle under triangles. So OM is the height of this triangle. OM will also bisect the line AB. That means that it will divide the line AB into 2 equal parts. So from A to M will be half of 5 centimeters, which is 2.5 centimeters. And from M to B is also half of 5 centimeters, which is 2.5 centimeters. Now, if you consider the points OAM, you will see that it forms this right angle triangle OAM, with OA as 5 centimeters and AM as 2.5 centimeters. And OM is the height of the triangle. So we can apply the Pythagoras theorem here to find OM. When we do that, you will see that AO squared is equal to AM squared plus MO squared. Remember, we are looking for MO or OM. So we have 5 squared is equal to 2.5 squared plus MO squared. When you simplify this, you are going to have MO is equal to 4.3 centimeters. What that means is that the height of the triangle is 4.3 centimeters. Okay, so the height of the triangular faces is 4.3 centimeters. Now, we have the base to be 5 centimeters and we have the height to be 4.3 centimeters. So we can find the area. Remember, the area of this triangle will be the same as the area of this triangle, and to be the same as area of this triangle, it will also be the same as area of this triangle. So area of all the triangular faces is equal to 4 times the area of this triangle, which is 4 times half times base, which is 5 centimeters, times the height, that is 4.3 centimeters. And this will give us 43 centimeters squared. So half times base, which is 5 centimeters, times height 4.3 centimeters is the area of this triangle. But since we have 4 identical triangles, the area of all the triangles will be 4 times half times 5 centimeters times 4.3 centimeters, and that will give us 43 centimeters squared. So the total surface area is equal to area of the square base, which we have already found, plus area of the triangular faces, which we have found here. Area of the square base, we found that to be 25 centimeters squared, and we have just found area of the triangular faces as 43 centimeters squared. So the total surface area of this pyramid is equal to 25 centimeters squared plus 43 centimeters squared, and that will give us 68 centimeters squared. So the total surface area of the pyramid is 68 centimeters squared. The question said we should find the volume of the pyramid, and we are going to do that in the next video. So see you in the next video, and let's continue solving this question.